Okay, so normally we got our double helix here. We got our histones that are acetylated, and there's because of that, there's essentially a polarity that makes these histones relax and causes them to open up some because they're not so attracted to each other, essentially. When these groups are attached here, it makes them accessible to RNA polymerase, which comes in and transcribes our RNA. That's typically how, when genes are expressed, that's what we want to happen. That's ideally, if it's a good gene, a regulatory gene, something that helps us maintain our control mechanisms. A lot of times that's what we like to see. That's how come you might have cells that are abnormal, but they're controlled because they're regulated. And along with that, we got HAT, or histone acetyltransferase, as these acetyl groups to here, and that's what kind of allows the polymerase to come in behind there and get everything going. What happens is occasionally we get a methyl group attached, and when that happens, all these acetalases, the acetyl groups come off of here. I'll try to do this quick. The acetyl groups come off. We've got a HDAC comes in here and attaches, and it causes this thing to bind up and wrap up tightly to where it's basically inaccessible to this polymerase anymore. When it's inaccessible, it's obviously not transcribing. So because of that, there's a lot of control mechanisms both ways in regards to if we want that or not, depending on what we want expressed. But typically, if something's heavily methylated for a long time, it is no longer active. Okay, real quick, DNA is methylated most commonly at CPG islands, where there's lots and lots of CPGs going on, and we're essentially adding this methyl group to it. Makes it almost like a stopper for our transcribing. Main enzymes we're talking about here are HDAC, which actually is removes the acetyl group, makes it bind up, and HAT, or HAT transferase, makes the acetyl happen. But anyway, a couple things to consider is that both of them are control mechanisms for whether something should be expressed or not. But we can actually alter our diet that helps that control mechanism to begin with. Currently, there's drugs classified as HDAC inhibitors. They show promise and real potential for cancer in clinical trials. So that being said, natural histone deacetylase inhibitors, such as sulforaphane, which is found over here in broccoli and cruciferous vegetables, are especially high in broccoli sprouts and that sort of thing. But altering your diet can actually affect your epigenetics and how well you're able to fight and maintain your control mechanism so these things don't get out of hand.